Hello, everyone, and a very good afternoon. Dear authors, session chairs, and invited guests, welcome to Technical Session 9D. Myself, Samruddhi Mogal, and I will be the moderator for this session. On behalf of Global Knowledge Research Foundation and Geoscholastic, it is my great pleasure to welcome you to the 10th World Conference on the Information Communication System, Software Security and Sustainability, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was successfully held yesterday in London, UK, and the virtual event is being conducted through Zoom from 29th to 30 July 2026. I hope you all enjoy today's informative, insightful, and interactive technical session. In this session, we have six paper presentations. Each presenter will be allotted 12 minutes for the presentation, followed by 3 minutes for the question and answer session. I will give a gentle reminder when 10 minutes have elapsed to help you manage your time. I would also like to request all participants to kindly stay connected with us until the closing remarks of the session. If you have any queries or require any assistance during the session, please feel free to write to me in the chat box. Before we begin the presentation, I would like to introduce the distinguished session chair for this technical session. Today we have Dr. Nalinikant Joshi sir. Dr. Nalinikant Joshi sir is the director and professor at the Modi Institute of Management and Technology, Kota, India. He brings over 25 years of extensive experience in academic research and institutional administration, contributing significantly to higher education leadership and development. May I now request our respected session chair to kindly share a few words, offer their valuable insights, and guide the presenters before we begin today's session.
So, thank you, Samruddin. It's been an honor for me to participate in a part of this conference. And I remember that I was there last year also, conference organized by the GRE. And I hope all the six paper assigned for today's session will be a great and very knowledgeable. And at the end of this session, we'll definitely get some insight about what's going on in the software security and the sustainability. All the best to all the participants. Thank you.
Thank you so much, sir, for your valuable guidance. Now let us begin with today's paper presentation. Our first presenter is Samira Bolabel Bachari. The paper title is Assessing Digital Governance Transformation Trajectories in MENA Countries and Entropy, Topsis, and Hierarchical Clustering Approach. You may start your presentation.
Good morning. Can I share the screen, please? Can you let me share the screen, please?
Yes, you can.
So, good morning, everyone. First of all, I would like to sincerely thank the organizer for giving us the opportunity to present our work at this conference. My name is Samira Boulhbal from the Research Center in Applied Mathematics in Algeria. Today, I'm pleased to present our work entitled Assessing Digital Governance Transformation Trajectories in MENA country, an entropy topsis and hierarchical clustering approach. This work was conducted in collaboration with Dr. Hind Debslamani. From this research addressed the following question: how can we better understand the way countries transform their digital governance over time, rather than simply comparing their current levels of performance? So today we live in a world where almost everything is measured. To make sense of increasingly complex phenomena, we rely on composite scores that summarize multiple dimensions into a single measure. They provide a concise representation of reality and greatly facilitate comparison. However, reducing complexity to a single score inevitably leaves part of the story untold. Understanding transformation requires looking beyond static performance. This is the central idea behind our work. This challenge is particularly evident in the field of digital governance. Several well-established frameworks, including the United Nations EGDI, the Digital Government Index, and the World Bank GovTech Maturity Index, have become the main references for assessing digital government. They have made an important contribution by enabling countries to benchmark their performance, monitor their progress, and compare their results. However, these frameworks are primarily designed to answer one question: where do countries stand? They measure current performance and produce ranking, but they tell us very little about how countries have evolved to reach their current position. As a result, they tend to overlook transformation dynamics, institutional pathways, and the multidimensional nature of change. Consequently, similar scores do not necessarily reflect similar transformation trajectories. To address this limitation, we propose a different perspectives. Just 1 minute, I didn't put the presentation. Presentation. Sorry.
Your screen is visible.
Just
Can
1 minute.
present.
Voila. This is much better now. No. There is no sharing screen now.
No, your screen is not visible.
The sharing screen.
It is in the bottom menu, please. You may see it.
Sorry, I'm really sorry.
Please look at the bottom menu. Menu at the bottom line.
But, I will share. I think the PDF. It will be more.
You can open your presentation in PowerPoint presentation, like PPT,
I will
not in
put all
PDF.
the screen in.
Your screen is visible now.
Yes,
You
we
are
can see.
seeing the slides.
We can see. Yes, yes. Continue.
Now
Yes,
it is
yes,
okay.
it's visible.
Sorry. Now, I continue.
It's okay now.
It's okay. Thank you. Sorry. So this challenge is particularly evident in the field of digital governance. Several well-established framework. I think I presented this one. Static. Yes. Next slide. Okay. Oh. Our analysis focuses on digital governance transformation by examining countries' trajectories of change over the period 2010 to 2024. This perspective allows us to measure transformation to identify countries that follow similar trajectories and compare different transformation paths. By looking beyond ranking alone, we are able to reveal hidden dynamics, distinguish countries with similar performance but different patterns of evolution, and provide stronger evidence to support policymaking. Ultimately, we argue that digital governance should be assessed through transformation trajectories rather than performance levels alone. So our empirical analysis focuses on the MENA region. We selected this region because it offers a particularly interesting setting for studying digital governance transformation. On the one hand, MENA countries share a common regional context and face many similar challenges. On the other hand, they differ considerably in their institutional setting, economic structure, digital strategies, and the pace of governance reforms. This combination of common regional characteristics and substantial national diversity creates an ideal setting for comparing different patterns of digital transformation. To personalize this approach, we designed the study around the following framework. Our analysis covered 13 MENA countries over the period from 2010 to 2024 with the objective of measuring progress rather than static performance. To capture this evolution, we structured the analysis around three analytical dimensions. These dimensions are measured through the 7 complementary indicators selected to capture the key aspects of digital governance transformation. The data were obtained from 3 international recognized sources. This framework ultimately allows us to construct digital governance transformation trajectories for each country. Once the framework was established, we implemented a multi-step analytical procedure. We first transformed the original indicator into progress indicators, allowing us to measure change over time rather than static levels. The indicators were then normalized to ensure comparability and weighted using the entropy methods so that more informative indicators received greater importance. Based on these weighted indicator, we applied TOPSIS to assess each country's proximity to the ideal transformation trajectory. We used hierarchical clustering to identify groups of countries following similar patterns of digital governance transformation. Finally, we assessed the robustness of our findings by comparing the results with principal component analysis and Vicar. Together, these steps provide a robust framework for analyzing digital governance transformation trajectories. Before identifying transformation trajectories, it's important to understand the role played by each indicator. We first examined their relative contribution using the entropy weights. As shown in the chart, the e-participation index received the highest weight, indicating that it's the most discriminating indicator across the MENA countries. It's followed by the inline service index, whereas the corruption perception index received the lowest weight. The correlation matrix provides additional insight into the relationships between the indicator. The strongest positive correlation is observed between e-participation index and the inline service index. suggesting that improvement in citizen participation are closely associated with advance in online public service delivery. For the overall transformation trajectories identified using the TOPSIS approach, the ranking shows that Saudi Arabia achieved the highest score, followed by Turkey, Oman, and the United Arab Emirates, while Lebanon and Tunisia occupy the lowest position in our sample. Rather, it shows that digital governance transformation follows differentiated patterns across the MENA region, with countries reaching their current position through a different combination of institutional, technological, economic, and connectivity-related factors. These findings suggest that countries with similar regional contexts can follow very different transformation paths. To gain deeper insight into this result, we then examined whether countries followed similar transformation patterns. Hierarchical clustering revealed three distinct groups of countries sharing comparable digital governance trajectories. These similarities are not immediately visible from the overall ranking, highlighting the value of complementing TOPSIS with cluster analysis. To better understand these trajectories, we examined also the progress achieved by each country across the 7 indicators. The heat map clearly shows that progress is uneven across dimensions. For example, some countries achieve strong progress in online services but more limited improvement in institutional or economic conditions. These results confirm that digital governance transformation is multidimensional and does not follow a uniform sequence across countries. Finally, we assess the robustness of our findings using two complementary analyses. First, the comparison between TOPSIS, Vicar, and EGDI rankings shows a strong overall consistency. The highest and lowest ranking countries remain largely unchanged, while only few intermediate positions vary. Second, the PCI indicates that the country differences are explained by several complementary dimensions rather than by a single dominant factor. Together, these results support the robustness of our assessment of digital governance transformation trajectories. To conclude, our findings show that digital governance trajectories differ substantially across MENA countries. More importantly, similar performance levels do not necessarily reflect similar transformation trajectories, which are shaped by multiple institutional, technological, economic, and connectivity-related factors. Digital governance strategies should be tailored to countries' specific transformation pathways rather than relying on one-size-fits-all approaches. As a next step, we plan to extend the framework to additional countries, incorporate emerging dimensions such as AI, readiness, and cybersecurity, and complement the quantitative analysis with qualitative case study. Thank you for your attention, and sorry for the part of the screen sharing. Thank you.
Thank you so much. Do we have any question from session chair?
So, Samaira,
Yes.
it's a good presentation. Concept was very good, and especially the TOPSIS, multi criteria. Um, that looks very useful for this study, and can work on this further. Then it can be useful for those countries you shown in your second last slide, that the TOPSIS ranking for the intermediate countries is different than the top rank countries. So it's a good concept. And presentation is also fair enough. Thank you.
Thank you. Thank you. Thank you.
Thank you so much, sir. Thank you so much, ma'am. With that, let's move towards our next presentation. Our next presenter is Mohammad Arfat Ullah, and the paper title is Behavioral Analysis of Machine Learning Techniques on Semiconductor Process Data for Fault Detection and Classification. You may start your presentation. Mohammed Mohammad Arfat Ullah, are you there?
Sorry for late
Please.
response. I'm here. Yes, I'm sharing. Currently, I'm sharing my screen. Mm. Oh, screens. Share. Can you see my screen? Sorry.
Yes, your screen is visible. You can
Yes,
start your
yes.
presentation.
Okay. I'm starting my presentation. Hello. My topic, my paper was regarding behavioral analysis of machine learning. Behavioral analysis of machine learning approaches on semiconductor process data. Okay. Usually, in semiconductor manufacturing steps, it contains of several steps such as wafer cleaning, coating, etching, annealing, oxidation, photolithography, ion implementation, and deposition. So why FDC needed? FDC means fault detection and classification. During those steps, since several tools are used for several steps, like for wafer cleaning, cleaning tools, for photolithography, photolithography tools. So if there if there was any defect, like which is not visible before during wafer processing, so then the lots of wafer would be damaged. So during complex manufacturing steps, wafer may pass through faulty processing tools. Early fault detection and classification, either run by run, like we already run wafer, then we found defect, or real time detects, could prevent catastrophic yield loss and saves substantial production costs. That's why we need FDC. So usually, traditionally, FDC is done through SPC, statistical process controls, which is like collecting previous data, like 1 month, 2 months of tools data, and then several parameters during wafer processing, such as temperature, pressure, what was the value, and uh, uh, then set a statistical parameter after discussing with process engineers, and uh, set a threshold value. If later wafer processing just those parameters value exceeded, later, like then that detect as a fault, and an automatic alarm pass through the tool, and the tool stop automatically. So that's traditional SPC, which includes like collecting parameters data and its value, and analyze like average, what should be the average or standard deviation, what should be the other statistical process metric. But this the problem is SPC is it cannot solve the multivariant problem. So that's why machine learning is coming. Once we train previous data, previous behavior through several machine learning models, then it can detect anomaly through itself, even its multivariant. So though several work done on this topic, like evaluated traditional ML and preprocessing on SECOM dataset, which is semiconductor process manufacturing dataset. Though this specific research focused only on the preprocessing steps, not the whole FDC steps. And another CNN transformer for same image defect segmentation work also done, but to use that only useful if the data is as image, like wafer image. Obtaining that is sometimes very complex because of their confidentiality in semiconductor process manufacturing data. And there are another works on GNs for time varying fault diagnosis, high complexity for fab deployment. That's the cons for this work. Also, there are another work using LSTM autoencoder for sequential monitoring, but these only focused on the deep neural networks over classical ML analysis. So in my work, most studies primarily, the work I mentioned, they primarily focus on either pre-processing or static feature classification or deep sequential learning, while limited work has explored converting static semiconductor process attributes into pseudo-temporal process signals for comparative fault analysis. To bridge this gap, our contribution investigates the behavioral classical machine learning approaches. What happens underneath, together with custom algorithm implementation on reconstructed semiconductor temporal signals. Since real-life semiconductor data manufacturing data is temporal, not like a feature or discrete. And the later, this is about the dataset we have used, like SECOM dataset, which is a public dataset for semiconductor manufacturing, which has 1567 wafer fabrication runs, and it has 591 anonymized process signal per wafer. But since several feature only contains constant value, so use dropped constant sensors containing using zero diagnostic value during pre-processing process, applied median attribute imputation for sensor gaps, and feature normalization using standard scalar. Final feature space, we used only 446, except the time features and the output features, which is whether the run was fault, fail, or pass. That's all about the dataset and brief pre-processing. And this is the methodology section where initially I have used baseline algorithm like from sklearn, use SVM, also in random forest classifiers to directly on the dataset, the pre-processed dataset, receive high accuracy 93.3, which is very high. But the problem was it was biased toward major class, the pass class. It does not give the actual class imbalance. Then also used custom KNN one, like distance based, which use Euclid distance based algorithm, like the which does not have any training phase, like before after splitting the data train into test and the test sample, calculate the distance between the test sample with all the trained samples, and then came into figure out the nearest neighbors, and then the which has more similar classes, and then throw the new sample would go through that class, which is the basic KNN, and later since the baseline algorithm like only gave the results but does not tell us what's happened underneath, how it's manipulating that data, what is happening. So that also the KNN, though that custom which does not have any training phases, so it may increase the cost if data samples increases. So I used SBM from scratch. It's like using, since it's doing this is calculation is slightly complex, I used only subset of 1,000 samples out of 15,000 samples to calculate the hand form the maximum margin objective, and form the dual optimization problem, and later solve custom sequential minimal optimization using Lagrange method with Scratch. Then what we found out, since the sample was simple, but the this model has been tested on the actual train set, but obtain the accuracy reduced, but it gives the better class imbalance. Now it was not biased toward the major class. Also applied the same custom linear SVM in kernel formulation, like
Sorry to
kernel.
interrupt. It's a gentle reminder that you have only 1 minute left to conclude your presentation.
Okay, then I applied custom Lagrange kernel version. Later, since the actual real life data is temporal, not feature, I applied I convert that data into temporal data, reduce dimension from 446 to 14, but 414, and applied same custom linear and custom kernel algorithm in that data set. And this is the result and discussion. We find out the custom KNN and is baseline SVM and random forest good accuracy, but not good class imbalance. But the custom linear SVM and custom kernel both provides better class imbalance. But the problem on custom kernel SVM was overfitting. All 1,000 support vectors becomes 1,000 samples becomes support vectors. Same I have done linear SBM, also kernel SBM to the temporal data and observe these results. In this case also in the kernel version, all support vector samples become support vectors, which is the drawback in this system we find. And the final conclusion, we want to say the SVM-based custom SVM provide more class imbalance than the base SVM. In the custom kernel SVM, all 1,000 samples become support vectors. The temporal approach reduces dimension significantly while preserving important characteristics. In future work may include imbalance handling techniques such as smart deep learning architecture, including LSTM and transfer models, real sequential semiconductor sensor data analysis, and real-time semiconductor process monitoring systems. That's all. Thank you. Is there any questions?
Thank you so much. Do we have any questions from session chair?
Basically, there is no question, but as a suggestion, I would like to say that it has written in the future scope of work was here sample size is small, but still analysis and result shows that uh, size of sample for current work is fair enough. But to make this research work more useful, some more data can be included and some changes may be done. All it's a good paper. Thank you.
Welcome. You're very welcome for your comments. Thank you.
Thank you so much, sir. Let's move on to our next presentation. Our next presenter is KBHMTT, Badra Bandara Nayake. The paper title is Explainable WSL Command Thread Detection using Machine Learning Risk Scoring and Retrieval Augmented LLM Reasoning. You may start your presentation.
Thank you, Samruddhi. Just give me a minute until I share my screen. Can anyone please tell me whether my screen is visible or not?
Yes, your screen is visible.
Right, perfect. Good day to you, everyone. So I'm presenting our work titled Explainable WSL Command Thread Detection using Machine Learning Risk Scoring and Retrieval Augmented LLM Reasoning. So it's kind of a long topic itself, but this work focuses on a security visibility challenge within Windows subsystem for Linux, or basically WSL. Our approach combines three main stages: observing command level activity and assigning an operational risk score to it using a machine learning model, and then generating a grounded analyst explanation using retrieval augmented reasoning. The broader objective is to create a foundation that can eventually support explainable and controlled detection and response workflows. So this is kind of like a stepping stone for AIDR, which is kind of being talked at the moment. So moving on, the project began from an operational visibility gap that I observed during an endpoint investigation during my trainee period. So the endpoint platform showed that WSL had been launched, but the available monitoring or the command level monitoring did not was not there actually. So the problem was not a complete lack of visibility. The problem was that the analyst could see the execution environment, but not always the detailed command behavior occurring inside of it. So this matters because commands carry intent: a download, a pipe into a shell, an interpreter wrapper, or else a suspicious path or an external address. So these things can reveal much more than simply knowing that WSL was started. Also, at the same time, Linux commands are highly dual use. A network scanner, a scripting interpreter, or administrative commands may be legitimate in one context and suspicious in another. So the commands are like kind of in a dual use manner. So this led to our research question: can WSL commands be mechanically detected, risk scored, and then explained clearly enough to support SOC decision making? So the paper we wrote about on this is like, first we treat Linux side WSL commands as security evidences rather than considering only the parent window process. And then secondly, we classify the command and convert the model output into an operational score from 0 to 100. This allows events to be prioritized as normal, suspicious, or malicious. Third, we use retrieval augmented reasoning. Instead of asking an LLM directly to explain the event using only its general knowledge, we first retrieve relevant attack content from MITRE attack surface and supply it as evidence. So finally, the one you see at the end, AIDR Foundation, is like the architecture that we are looking forward to build. That is kind of like what we want in the future in cybersecurity sector. That's like the architecture basically separates detection, reasoning, and response into three different categories or scenarios in the same streamlined workflow. So the evaluated contribution of this paper is the machine learning scoring and RAG-based explanation. So there's a dashboard as well, and the dashboard and mitigation workflows form part of the broader prototype and future AIDR detection. So if we talk about how this process begins with a structured WSL command event, which contains the command and the timestamp, the host, user, and process contents. The command is then converted into a lexical structure feature, as you can see here in the extract box. So this is kind of like feature engineering. These features represent both the text and the behavior of the command, including elements such as wrappers, pipes, redirections, URLs. So it's kind of character identity, TF, IDF methodology used there. So for the model, we use calibrated SVMs. Since they produce a risk score between 0 and 100, so we can have a probability in percentages. So based on this score, the event is categorized either as normal, suspicious, or malicious. So normal events can be stored for audit without further generative processing. Suspicious and malicious events are forwarded to a retrieval layer. So this retrieval layer hosts a vast backend. So when the malicious or suspicious events are brought towards the retrieval layer, ChromaDB searches for relevant attack knowledge that basically matches what came through towards the retrieval end. And the retrieved evidence is then passed to the LLM, which we have initiated in our system itself. The key design principle is that the LLM is not the primary detector. So LLM is there for a specific reason. I will explain in the coming slides. So machine learning answers how risky is the command, and then once it get into the retrieval layer, the RAG and the LLM layer answers. So this is why it has been risky. So why might it be risky, and what should be analyzed that should be reviewed? Those things are being answered by the RAG and LLM. So moving on, auto mitigation is also a part of our system, which we really worked harder on to have that mitigation feature within our system itself. So auto mitigation is controlled centrally by centrally, but like I have to put it clearly. This is executed locally at the endpoint. So our system, our final application itself acts as a CrowdStrike agent, if I can be bluntly enough. So the way we provision our application is sort of like provisioning agents to our endpoints. Yeah. So basically, how CrowdStrike works as well. So first, an administrator changes the mitigation setting or threshold through the dashboard. The dashboard sends this configuration through the backend API, and the configuration is stored in DynamoDB, which we have a high level architecture in AWS itself. The backend then pushes the updated policy to the live WSL agent through its WebSocket connection. So we have a WebSocket connection for that backend communication. The agent does not receive an arbitrary shell command. However, it receives configuration values such as whether auto mitigation is enabled and what risk threshold should be used for. And the agent continuously observes local processes and scores them using its local machine learning component. And also when auto mitigation is enabled and a process score exceeds the configured threshold. So let's say we have a configuration threshold from 0 to 1. So if the process score exceeds the configured threshold, the agent can flag or terminate the process right then and there. So that then and there the auto mitigation happens. Then an important distinction is that the current kill decision is endpoint local and threshold driven. The RAG explanation layer is currently a separate thing from the decision itself. So what we want to focus on in the future is to get that auto mitigation part through the AI implementation within the system itself. So if I can quickly go through this, the data set itself for the ML contained 8,028 commands. 4,850 of them were benign and 3,178 were malicious. So from these commands, we created 37 engineered fields representing command structure and security relevant behavior. So a major challenge in command classification, if I can quickly give it out to you guys, if the exact same command appears in both training and testing, the model may appear accurate simply because it has memorized the command which has been previously entered. So to reduce that, we have implemented leakage aware split, which will return from repeating command string descriptions, whether they were used in training sets or in test sets. So this produced 1606 test commands with no exact command string overlap between training and testings. So you can get the idea of it. So and also we have to make sure to let you know that we compared with 4 models: logistic regression, calibrated SVM, XGBoost, and complement naive base. And we have to be exact, since we use calibrated SVM. The reason was, as I told you earlier, the production of it is the strongest from the overall, and the performance and provided probability like output is suitable for the operational risk scoring that we look in our whole project. So moving on, this is kind of like the RAG workflow. So earlier I explained about the ML, now the RAG part. The RAG
Sorry to
process.
interrupt.
Yeah.
This is a gentle reminder that you have only 1 minute left to conclude your presentation.
Right, thank you. So the RAG process begins only for suspicious or malicious events. So basically, first thing, the command and its risk context are converted into a numerical meaning, and basically the representation, and it's called an embedding. I used a mini LM for this process, and then the ChromaDB compares that representation with the embeddings that the ChromaDB has in the database itself. So it retrieves the 4 most semantically similar records, and it's the number 4 is not a universal or mathematical optimal value. It was basically selected as a practical balance. So one record may provide too little context, while returning too many records can introduce irrelevant information. So we use Gemini, then receives the original command, and ML Risco extracted indicators and the attack context. So using those things, it generates a concise SOC-related verdict explaining the observed behavior, a possible attack mapping, confidence information, and also recommended investigation action, which is kind of like a gold opportunity for analysts in the future. So moving on, so I have explained here how ML and LLM have helped us in the whole productivity thing in this project. For machine learning classification, the calibrated SVM achieved 0.96 accuracy and 0.96 malicious class F1 score. And I have other results as well for the XGBoost and complement and logistic regression as given in the chart itself. So when it comes to the reasoning component, retrieval grounding produced clear improvements over standalone LLM reasoning, which if we rely on just LLM reasoning, we might have had less number of results. So MITA attack mapping accuracy increased from 52% to 87%, and also hallucinated statements decreased from 31% to 12%. And we have made sure to improve the consistency up from 3.1 to 4.6 with 1.5 increment, and also the relevance with 2.8 to 4.7. So how consider this example, this is a simple example. The curl downloads a remote script, and the pipe sends that content directly into bash for execution. So the feature extractor gets it and sends it to the feature signals, cut down into several parts, and then the ML model assigns a risk score of 91 and categorizes the event as malicious for the command that has been observed. So then the ChromaDB retrieves related attack records, and the reasoning layer combines that evidence with the command and risk score, and the analyst can get the result with the explanation, the recommendations, everything as per for the AI explained. So before I wrap up, so the current system demonstrates several parts of AI driven detection and response workflow. The command telemetry provides a mechanical signal. Machine learning prioritizes activity using a risk score. Then the RAG-based reasoning explains the behavior using retrieved evidence. And finally, the analyst can validate and escalate the event. The next integration is basically kind of what we are doing at the moment. I am in my industry area as well. So what I'm trying to do is I'm trying to build a unified policy controller with an AIDR layer. In that design, automated responses should not depend on the ML score alone. It should combine the score with reasoning confidence, attack context, identity, asset, criticality, and also organizational policy, which is a must in our scope. So low confidence or medium risk events can be escalated to a human analyst. High confidence, which things are basically satisfy or approve a policy, may be automatically flagged or basically contained or isolated. So these actions should remain reversible and auditable as well. These principles also extend beyond WSL. So in our perspective, we started from WSL, but we want to take it further ahead in endpoint detection as well, or cloud detection, whatever it is. So the common architectural principle is to detect mechanically, score consistently, reason using evidence, and respond under policy. So main takeaway, detection, reasoning, and response should be separated, then integrated carefully. So I have expressed what we have taken out from our side throughout the project. So it's for you guys to raise out your questions and know what you want to know. Thank you so much.
So you explained over here about in the last slide, there is ML accuracy is 0.96, right?
Yep.
But and the sample size is 8,000 and something.
I'm
But
sorry, I didn't get that.
sample size is 8,000 and
Yeah.
something numbers, no? So, but in a real world, the combination of commands would be very high and unpredictable as well.
Yeah.
There may be huge permutation combination of the commands. So, what will happen to your this model? By
This
considering
is
what there are two things. One is the size of the sample. Another one is the different combination. Means you explain it with one example of command HTTP URL and bash and all these things. If the command
yeah.
is very large, many parameters are there separated by slash, then your model should will work or not.
Thank you for the question. So we have tested it for different sizes of commands. Excuse me. So with that, so I hear you. I hear you. That's a valid question. So what we have implemented here is, so the dataset composition we see here is only with the ML part. So there's a separate dataset which is contained with the ChromaDB and the RAG. So whatever it is filtered through the ML, so it's like the basic, the base filtration is that happened through the ML part. So in that sense, what we thought was to, as for getting into this project, to have a low amount of samples with a lesser number of combinations, but with integrating it with the RAG and the LLM. LLM is used for reasoning part, but the RAG and whole ChromaDB part, we have enhanced that sample, how can I say it, the amount of samples in order to combine them and create the patterns, as you said. We have made sure those things are currently aligned, and there are tests that we have ran also in the dashboard itself. I can show you if you want. So yeah, I can hear you, but this is kind of
No, no,
like
no. It's okay, okay. It's fair enough. What you explain is fair, good enough.
thank you.
Okay, thank you, thank you.
Thank you, sir. Let's move on to our next presentation. Our next presenter is Pavel E. Zukov, and the paper title is Future Financial Crisis, Fiscal and monetary policy bedding plant date unknown. You may start your presentation.
Okay, thank you very much. Well, can I share with my screen, right?
Yes, you can present your screen.
Okay, I'm sharing with my screen. So do you see my screen? Do you see it?
Yes, your screen is visible.
Yes, we can see.
Okay, I start demonstration. Okay, this first slide. Well, sorry, my theme maybe is not exactly compliant with the theme of conference. Sorry for that. I didn't detect it the first time, but then it was too late to change it. So, but it is devoted to the macroeconomics. But I use some regression, so maybe it is why it was set by organizers in this section. The Finnish financial crisis. I am writing about fiscal monetary policy wedging. Fiscal monetary policy wedging means using credit emission by a central bank to finance budget deficit. The term that was actually introduced by Bassett and Thomas Sargent in their last work. Well, let's see it. Well, that's just three quotes. That's by Karl Marx. The host is Walking in Europe, the host of communism. It is about credit emission. Compound interest is the most powerful force in the universe. It is why credit emission will lead us to the financial crisis. And that's mine. That's mine. Money don't come from nowhere and don't vanish in emptiness. But no, don't apply it to a central bank, please. Usually, anybody who tells you that money comes from nowhere and vanish in emptiness is fraud. Do you agree with this sentence? As well, it is a phrase that I always used to tell to students. Yeah, but of course, it shouldn't be applied to central bank because the central bank creates money, and also maybe he makes it vanish. Okay, so first, in the 21st century, the beginning of the 21st century, after 2004, all developed countries and some developing countries too, of course. I don't know what about China. China is now a rather developed countries, I think, because it is a leader in economic growth. So I think in economic value, in economic GDP. So anyway, most of the countries use new Keynesian model for central bank. This new Keynesian model is actually attributed to control inflation, the so-called inflation targeting. And this model doesn't include any explicit restrictions on the money supply, which is very controversial by my understanding, by my judging. And I'm not sure that these models will have a good end at the end of the story. I'm sorry, probably they will drive us to the credit emission, uncontrolled credit emission to cover a budget deficit. That's what I think. Okay, so causes and causes for high inflation. Germany, twice Russia, Latin American countries, and many others, many African countries also comes through the period of hyperinflations. And even now, a very high inflation may be observed in Argentina and Turkey. However, these countries are rather prosperous, I think, very well and very good parameters of economic development. But unfortunately, the quality of monetary policy is low, and that's why. So causes of extremely high inflation and hyperinflation always may be explained by shotgun wedding of fiscal and monetary policies. Again, shotgun wedding means state budget deficit financed through credit emission. The common paradigm is now the neutrality of money for real economy, especially for inflation. In a country with low and well-anchored inflation, neutrality of money for inflation may be proved. Yes, you may check this statement with some tests. Well, I mean, wow. I mean, so you may provide some tests of the dependencies. Well, I mean, just usual regressions, or maybe log regressions, whatever you prefer. Well, so many, actually, I think that a lot of actually economic tools usually are based on regression, one a sort of another. Very few of them are not based on regression. But so my check also is based on regression, very simple regression. And we saw in the 2020 after COVID-19 disease pandemic, we saw that USA and European Union countries meet a peak in inflation, 10%. It may be explained by large-scale payments that were designed to cover the losses of business and persons during pandemic. And in USA, the special law was adopted, Inflation Reduction Act. It was adopted and it was enacted. And member of executive board of European Central Bank, Isabel Schnabel, raises this question whether the increase in excess money growth in 2020 was an early and sufficiently strong warning. Her answer is controversial. She told that in long term, yes, it may be. It may be somewhere some of ties, some of courses, but in short term, there are no signs. I mean, she means that money issue, volume of money issue made by central bank generally may not be directly connected with inflation. That's true. In general, it is not, especially in cases if inflation is well anchored. Well, it is my work. It is one of my work. What it was published 2025. When central bank control prime rate and ignore money supply, the market price for capital is distorted. So, three factors may come into play, and those three factors accelerate inflation. And all are ignored by human case and models. Well, theoretical. Sorry, I don't see. Okay, theoretically, fiscal policy and inflation may be covered by some models. Well, all the models, Kagan, Sargent Wells, Borden Fisher, and in particular in Sargent Wells model, when public debt grows faster than GDP, the T moments comes where the volume of public debt exceeds a reasonable share of the wealth that people are ready to devote to buy government bonds. And after that, all the deficit is financed by central bank. That is what comes. And this moment is enacted in Japan, for example, because of their specific policy. However, Japan now changed their policy. Change it. Well, the latest work. The latest works by Seta Sargent, Cochrane John, and my work. Well, some numbers. In Japan, it exceeds 230%, but Japan is now already in downward trend, which means that Japan changed its fiscal policy. Well, in a special case, well, I will not devote too much time because it of course it deserves a special report. In Japan case, it is very complicated, but to some extent, it is covered in my work. Okay, so this is the model of growth of debt. It is based on the previous debt and interest that was paid. The model and the result is exponential growth. That's what I want. Exponential growth. The equation 2 is exponential growth. Means exponential growth of the debt to GDP ratio. So for empirical evaluation, I just used very simple model. And provide regression. Regression showed valid results, and what I get from regression is average speed of the growth 5%. And with that speed, we'll get the red line of crisis during approximately 15-20 years, if fiscal policy will not change. Of course, that is a big if, but you know that the great financial crisis in the biggest countries like United States and European Union probably may mean the financial crisis with scales like Great Recession or maybe even Great Depression of the 30s. If you know this case was very, very cruel. Well, the onset of crisis may be accelerated by some events, maybe rapid increase in spending on social programs, health insurance programs, like United States, there are Medicare, Medicaid, or ineffective programs to stimulate the economy, government stimulation. By the way, some ineffective programs to stimulate the economy were provided in Japan by 3 arrows plan. Okay, so with a growth rate with 5%, US debt to GDP ratio will cover the distance during red line is by about 12%. It is estimated by the pattern of inflation peak in COVID crisis. That means that future financial crisis will take place exactly 2041 or 2046. There are unpredictability, some probability, and of course it may happen or may not happen at all, or may happen earlier, depending on external factors and financial policy. But exponential growth of debt, at a rate exceeding GDP growth, eventually leads to full-scale financial crisis. That's sure, for sure. Okay, so it is obvious that United States and Japan have to introduce a VAT and don't increase
Sorry
customs.
to interrupt.
Sorry?
Sorry to interrupt. It's a gentle reminder that you have only 1 minute left for your presentation.
What about Japan? Sorry, repeat. I don't hear you.
Sorry
Please,
to interrupt. It's a gentle reminder that you have only 1 minute left to continue your presentation.
what about Japan? Sorry. United States and Japan are the two only countries, developed countries, that don't have value tax. That's very strange. That's ridiculous. That may be explained by political factors, and that is a very important factor. Very important factor. Why they don't cannot cover budget deficit? If they introduce a value tax, then United States might not need to increase custom taxes. Of course, increasing custom taxes that is made by Trump administration is also ridiculous, even more. It's cruel. Actually, it is more declarative. But anyway, if they introduce a value tax, the economy may be more compatible, and they might not need in so big budget deficit to cover budget expense. Did I answer your question? I don't understand. I don't get it exactly. You told us something about Japan, but I don't get the sense of. Sorry? Okay. In order to accelerate economic growth, it is necessary to shift fiscal policy priorities from the development of infrastructure and social programs, which is now the most popular in theoretical economies, but to research and development. That will increase labor productivity. Especially it is important for Japan, by the way, because a three-arrow Abe, Shinzo Abe plan was also completely devoted to infrastructure and institutions and monetary policy, which is wrong. But none don't cover anything about research and development. It's why Japan lose its competition with more competitive countries like China, South Korea, maybe some others. Generally, all social programs have to be audited. Specific to the United States, it is health insurance reform and limiting the growth of budget deficit due to Medicare and Medicaid. Medicare and Medicaid programs are the main reason for their growth of United States budget. So that's the most dangerous. Not military programs, but even just that. Perhaps national companies with a high degree of localization should be stimulated with tax incentives for corporate income tax and shareholder income tax. It's for all the countries, developing, and for all the countries, it's very important. Developing countries use it, but in limited. Okay, this references. That's some most relevant work highlighted with red. And thank you for attention. Okay, so if you have any question, I
Thank you
waited.
so much. Do we have any question from session chair?
It's a good paper and good presentation as well. All the facts are well analyzed, and at the end, the recommendation you have presented was all in all at a good level. And of course, it will depend on the different priorities of the government. Uh, let's say you explain that shifting the attention from infrastructure, social reforms to the R&D. So definitely, there must be a balance in these factors in the future. So it's a good paper. Thank you.
Thank you very much. But I didn't understand what you asked me. What do you want an answer for the question? If you want to answer, please repeat the question exactly. Point the
No,
question.
there is no question from my side.
Do you
It's
have
a
a
good
question?
paper. Thank you. No question. No question. Thank you.
Thank you very much. Well, and if you want to find some, you may find it in my work. Any more details in work, and maybe in some other works on this topic. Thank you.
No,
Sorry for this.
it's a good work, nah.
Sorry.
Your work is
Again.
very good.
Yeah. Thank you very much. Thank you for asking. Okay.
Thank you.
So well.
Thank you.
So if you do.
Thank you so much, sir. Thank you so much, sir.
Thank you.
So with that, we'll move toward our next presentation. Our next presenter is Unnati Parmar, and the paper title is Lexicographical and Morphographical Approaches for Gujarati Dialect Identification, a Systematic Survey 2021 to 2025. You may start your presentation, ma'am.
Yes, thank you, ma'am. Is my PPT is visible?
Yes, ma'am. Yes, your screen is visible.
So, good evening, everyone. My name is Unnati Parmar from the Faculty of Computer Application and Information Technology at GLS University, Ahmedabad. This work is guided by Dr. Jatin Mode, also from FCIT, GLS University. I'll be presenting paper ID 478, Lexicographical and Morphological Approaches for Gujarati Dialect Identification, a Systematic Survey 21 to 25. Here's how the talk is structured. I'll start with the introduction and motivation, then our research objectives, followed by the LR, our methodology, results and discussion, our conclusion, and finally we are going for the references. So Gujarati is the official language of the Indian state of Gujarat, spoken by over 62 million people, uh, placing it among the world's top 30 languages by speaker count. Despite that scale, Gujarati has long been classified as least resourced and least researched in NLP, primarily due to a shortage of annotated data. Part of the difficulty is linguistic. Gujarati is agglutinative and highly inflectional. A single verb root can produce hundreds of surface forms through suffixation alone. And the core challenge we address is the dialect continuum. Standard Gujarati differs sharply from various other dialects like Kathiawadi, Suti, Charutari, and Patni. That is phonetically, structurally, and lexically. So, uh, if we're talking about the Kutchi, so Kutchi sits apart still, bordering Sindhi linguistically. So the questions we are tracking is how do we identify these dialects computationally from text alone? So we set five objectives for this review. The first two are on the slide. That is first objective, which is systematically map the 21 to 25 literature, surveying Scopus, IEEE Explore, and Google Scholar for Computation Gujarati dialect identification research. Following that, Prisma guideline for a transparent and a reproducible process. Uh, Second objective we have, that is characterize dialect markers, identifying the morphological, lexicographically, and orthographic features that distinguish Standard Gujarati from its regional dialects. Continuing with this objective 3 through 5, that is uh, compare computational methodologies, which is benchmarking rule-based systems, deep learning approaches like bidirectional LSTM and BOT, and newer LLM-based approaches across morphology, idioms, and STEM tasks. Then exposes resource gaps, pinpointing underserved dialects like Kutchi and Patni, and challenges such as code mixed, which is with the we can say Gujlish, Gujarati and English, which is with social media text we have. Then, based on this of the things, we just think of to propose a particular hybrid path forward, that a framework combining rule-based linguistic precision with deep learning adaptability, aimed at more equitable dialect to NLP. So, with this objective sets, let's move with the literature review. So in this, the literature clusters with this into T strands. Here are the first two we have morphological analysis and tagging. So that is by LSTM trained on the gold standard which morph corps, over 16,500 words. Reached with the 0.99 F1 score for root and affix identification. Joint models predicting morphology and part of speech together still reached 0.98. Then lexicographical idiom detection. Dialects like Kathiawadi are often identified through idioms, or we can say Rudy Prayog. So, dynamic phrase generation detects this inflected idioms at 99.73% accuracy, and 8-bit Unicode diacritic extraction reaches 99.58%. And Indo-coordinate integration further improve contextual recognition of ambiguous regional idioms. The third strand cars stemming lemmatization and supporting tools, try-based stammer speed of processing, and GPT-4 based context aware stemming reaches at 94.26% F score, and traditional rule based stemmers, which is ruled at own 96.63% accuracy, and DFA based lemmatization achieves a 16% vocabulary reduction, which meaningfully improves the downstream topic modeling. So based on that, we have a performance benchmark table, which is this table summarizes the best performing methodology for each major task. So for morphological analysis, bidirectional LSTM is the leader, improving F1 score over baseline. For idiom detection, dynamic suffix logic from mode and Sani reaches 99.73% accuracy. For POS tagging, deep learning approaches from Mehta and the other authors report strong accuracy. For spell correction, Panchal and Shah combine the knowing algorithm with grammatical rules. Through a specific accuracy figure isn't reported in that work. And for dialect translation, Thakkar et al. Use model adaptation with reported improvement over baseline system. Now here it is. Let's look at the individual studies in more depth. That is Bakshi and Bird's 2024 bidirectional LSTM-based morphological analyzer improved accuracy over baseline systems through root and feature predictions. Mehta et al. Also 2024 ran a comparative analysis for POS taggers using RNN, LSTM, and BERT. And RNN LSTM reaches 98.02% accuracy, outperforming BERT in this setting, which I'll come back to shortly. And Kaur and Patel in 2025 used an LLM's approach for stemming, reaches 96.7% precision, showing large language models are starting to enter the space too. Continuing the survey, Thakkar et al., that is 2025, used neural machine translation to translate Saurashtra dialect text into standard Gujarati using NLLB. Then Chauhan et al. 2023 applied DFA-based lemmatization for topic modeling, achieving a 16% vocabulary reduction. Bakshi et al. 2022 created GUJMORPH, the first gold standard morphological dataset with over 16,500 unique words, which much of the later work builds on. Uh, then Mode and Sani 2021 introduced uh, rule-based dynamic presentation for detecting inflected regional idioms at 99.58% accuracy. And Patel and Patel also 2021 used rule-based stemming for web page categorization on the MIL corpus of 96.63% accuracy. Now, how did we conduct this review? So we follow a Prisma guided systematic process for reproducibility, searching Scopus, IEEE Explore, and Google Scholar with a structured query, Gujarati or Indo-Aryan combined with dialect identification or morphological variation or lexicographical analysis. We included the peer-reviewed papers presenting textual computation dialect models and excluded generalized South Asian language surveys and acoustic-only speech system. We just excluded this because we just focus on the specific on text, that is dialect. Then we organize that field into the taxonomy of three layers. The morphology layer covers root suffix boundary, detection in verb and noun inflection. The lexicographically layers covered idioms and reproduce and specialized regional vocabulary, and the orthographical layer covers vowel mutation, consonant softening, and diacritics. So this taxonomy is what lets us organize a fragmented literature into a coherent structure, and it sets up the result one want to show you now. So here it is. This is how the result. That, for example, we have a word boy, which is standard Gujarati uses the chokro. Kathiawadi uses that choro or gavo, and Suti uses the poiro. So three different words for the same concept. And for the verb suffix meaning I do, standard Gujarati is karuchu. Kathiawadi replaces that with karusu, and Suti uses that kartochu. So that is how it gives the difference between suffixes. And for to sit, standard is besu. Kathiawadi soften to behnu, and Surti alternates between besni or behni. So that is these are the these aren't random. They are systematic patterns, and that systematically is exactly what makes them learnable directly from text by character label models. So here's one of the more counterintuitive finding in this low resource setting. Character level by LSTN actually outperform bot style transformer on Gujarati pure stringing. So two structural reasons explains this. First is tokenization dilution. Subword tokenizer like BP split turns in dialect variants such as Kutchi or Kathiawadi terms into meaningless fragments, diluting the semantic signal. Second, parameter overfitting. Transformers are heavily parameterized and overfit on the small regional data sets available. While character level BiLSTMs uses a smaller parameter space to capture sequential support patterns without needing massive training data. For example, mapping that Kathiawadi suffix su against the standard chu. So that is bigger isn't automatically better. Your model choices need to match that date regime. So even with this strong results, the resource scarcity paradox runs throughout the field. That 0.99 F1 score on Gujmov is a gold standard number. Performance drops noticeably on informal or out of domain text. So two gaps stand over here. First, understudied dialects, that is Kutchi and Patni, and others also, Charotari, Kathiawadi, and all. That is like any foundational label text, leaving the two most distinct varieties that list supported. Second, we have standard only corpora, that is from reference dataset like LDCIL, focus almost exclusively on standard Gujarati, sidelining regional variations from the start. Uh, Then two more gaps, which is digital code mixing. Social media brings in that is Gujlis, Gujarati and English mix. Chatbots also. Gujarati mixed with English, which causes high ambiguity and degrades both traditional analyzers and baseline. So LSTMs and translation evaluation, the metrics we use to judge like to standard. Translation quality is still really on baseline string matching, missing true structural nuances. Uh, so here we are going with the conclusion that to bring this together, Gujarati dialect identification has matured from a deterministic rule-based algorithm into a genuine neural subdiscipline. Character label models excel at morphology boundary detection and idiom recognition on gold standard data. But the core finding I want you to leave with this lexicographical variation remains the most reliable signal for distinguished dialect that share nearly identical grammatical frameworks. So that said, a significant gap remains for informal code mixed text, and closing it will require hybrid rule-based plus deep learning systems. So, which is the path forward we are proposing. Ultimately, the goal is that equitable NLP support for under-resourced dialects like Kutchi and Patni. So, I have listed the key references supporting this work here, spanning the morphological, lexicographical, and computational methodology studies I have discussed throughout the talk, and the remaining references continued here, including the resource gap and code mixing studies. The complete reference list is available in an accompanying paper of anyone who would like to follow up. So, thank you very much for your time and attention.
Thank you so much, ma'am. Do we have any question from session chair?
Uh, Question is not there from my side, but I would like to appreciate this paper. Unnati, your work is good. Your idea is very unique to
Thank you so much, sir.
analyze the language and their different dialects in different part of the Gujarat, Kutchi and Surat and all those. So
Thank you so much, sir.
I would see a very good future for this approach because the same approach, if someone works on your research or you yourself work, then as we know in India, we have five south states.
Yes,
These southern states have some similarity in their language and some similarity, like you explained in the Gujarati. So some concept can be applicable to make your work at a large level, and NLP support for those languages that can be done. So it's a good concept and good presentation.
Thank you so much, sir. Thank you so much.
And I also don't know Gujarati, Nati Avati. Okay, thank you.
Okay, thank you, sir.
Thank you, sir. Thank you, ma'am. With that, let's move on to the next presentation. Our next presenter is Gabriel De Vito, and the paper title is Machine Learning Enhanced Non-Invasive Test for MSLD SDNN versus FIB4 Tabular Foundation Models and Large Language Models. You may start your presentation, sir.
Thank you. Can you confirm that you can see my screen?
Yes, sir, your screen is visible.
Perfect. Good morning, everyone, and thank you for being here. I'm Gabriele De Vito from the University of Salerno, and today I'm proud to present our latest work titled Machine Learning Enhanced Non-Invasive Tests for MSLD Fibrosis. Let's start with a practical question. That is, can artificial intelligence improve an established clinical test without requiring any additional information from the patient? Well, before diving into details, let me contextualize our work, and then we will answer these questions as soon as possible. MSLD is the most common chronic liver disease worldwide. It is closely associated with obesity, type 2 diabetes, metabolic syndrome, and so on and so forth. As fibrosis progresses, the liver gradually loses its normal structure and function, and patient becomes at risk of cirrhosis, liver failure, and ultimately liver-related death. So from a clinical perspective, the key question is not simply whether a patient has MSLD, but whether they have advanced fibrosis, right? So those are the patients who need closer monitoring and specialist care. The reference standards in this field for staging is liver biopsy. But biopsy is invasive, expensive, and cannot realistically screen millions of patients, right? For this reason, clinical practice increasingly relies on non-invasive tests, and among them, one of the most widely used is FIB4. The As I can say, the question we ask in this work is whether modern AI can improve FIB4-based fibrosis assessment, but without changing the input space at all. Every model in this study receives exactly the same 5 variables. I mean, age, the FIB4 score, AST, platelets, and ALT. The key constraints is the wood point. It means any improvement we observe cannot come from new information. It keeps the clinical workflow identical, and it puts a ceiling on how large a gain we could possibly show. This motivated what we call a machine learning enhanced non-invasive test. The concept is more or less straightforward. Instead of replacing an established clinical score, we replace only its decision mechanism. Many AI studies, for instance, improve performance by adding more data. This is perfectly reasonable scientifically, but it also changes clinical workflows. Our goal is a little bit different. We want to introduce an upgrade that can be deployed behind existing clinical pathways, but without requiring a clinician to collect anything new. Formally, it rests on 3 constraints: input isolation, workflow invariance, and decision enhancement. To this aim, we used a few models, and among them, we developed a small deep neural network. It is a feed-forward neural network with 3 dense layers containing 75 and 23 neurons. In total, only 354 trainable parameters. But it is large enough to learn a nonlinear relationship among the variables, and still small enough to be easy to audit, validate, and integrate into clinical workflows. One detail you may notice is that the layer widths are chosen from small odd prime numbers. This is simply a reproducible design heuristic for exploring compact architecture. We are not claiming prime numbers are mathematically optimal. We evaluated all models using three biopsy-validated MSLD cohorts, previously published by Zheng and colleagues. The Chinese cohort was used for training, for development. The Malaysian and Indian cohorts were kept separate and used exclusively for external validation. We compared different approaches. First, conventional FIB4, second, our compact neural network, third, TAB-PFN, currently one of the stronger foundation model for tabular data. And finally, GPT-4o, evaluated both zero-shot and after supervised fine-tuning. By the way, we fixed the classification threshold at 0.5 before evaluating the external cohorts in order to avoid optimistic bias and made the comparison as rigorous as possible. We first evaluated if there was enough signal in the 5 variables we used. In the development cohort, age, FIB4, AST, and platelets are all significantly associated with advanced fibrosis. FIB4 is the stronger single predictor, by the way. On the other hand, ALT on its own, it's not significant. But here is an interesting point. When we remove AST, TBFN loses 3 AUC points, while our neural network loses only 1. In other words, the compact model spreads information across the correlated inputs rather than leaning on a single variable, which is exactly the behavior you want from a model that has to generalize to new populations, right? This slide contains the main results of the study. Let me summarize it in 3 observations. First, FIB4 performs reasonably well in Malaysia, but its performance drops in the Indian cohort. This illustrates a core limitation of fixed formulas. They do not always generalize equally well across different populations. Second, and I will return on this point in the next slide, TEP-PFN achieved very high specificity, but at the expense of sensitivity. Third, our compact neural network produced the highest threshold-based AUC in both external cohorts. And I want to be honest about the confidence intervals on this plot. They overlap. We are not powered for a definite claim that one model beats another, and we do not make one. Because AUC alone can hide what really matters clinically, let's examine which errors a model makes. TEP-PFN reaches high specificity in Malaysia, but its sensitivity is low. Our neural network, by contrast, gives the most balanced profile in both cohorts. What do I want to mean? For a first-line screening tool, this balance is clinically decisive because missing a patient with advanced fibrosis has direct consequences for treatments. And someone could argue, and what about large language models? Well, fine-tuning clearly helps over zero-shot, but it never uniformly beats a 354-parameter network. Of course, the operating point is only one lens. When we evaluate continuous discrimination instead of a fixed threshold, the ranking changes. In Malaysia, calibrated FIB4 achieves the highest continuous AUC. In India, our neural network performs best. We also looked at calibration and feature importance. The deep neural network consistently relied most heavily on AST and the FIB4 score itself, which is clinically reassuring, by the way. The broader message here is that no single metric should decide on its own whether a model is useful. They need to be read together. Let's also examine an aspect that often receives little attention, that is model size. Our neural network contains only 354 parameters, as I said before, right? TBFN contains more than 7 million parameters. In clinical deployment, compact models have real advantages. They are easier to validate, to version, to audit, and also to integrate in decision support system. And decision curve analysis reinforces the nuance from the slides we have seen before. No model was universally superior. TBFN gave the highest net benefit in Malaysia, where our deep neural network performed best in India. This is exactly why local calibration matters, rather than assuming one model will win everywhere. But every study has limitation, and ours is no exception. First, we intentionally restricted the available information to the variables already contained in FIB4, which inevitably limits the maximum achievable performance. Second, although we performed external validation, the validation cohorts remain relatively small, and the study is not powered for definitive pairwise superiority. Third, we fixed the operating threshold rather than optimizing it per cohort. And finally, the language model results depend on prompt design. This is always true. A fine-tuning strategy and model version count as well. This limitation define clear direction for future work. Let me finish with 4 key messages. First, a compact machine learning model can improve fibrosis assessment using exactly the same information clinicians already collect today. Second, bigger models were not automatically better. Third, performance depends on the population and on the chosen operating threshold. So local calibration should be considered an essential part of clinical implementation. And fourth, our model did not discover new biology. It simply extracted more value from information that was already available. We believe this is an important direction for clinically deployable AI, not necessarily collecting more data, but maybe making better use of the data we already have. Thank you very much for your attention.
Thank you, sir. Do we have any questions from session chair?
No, there is no question. He presented very good paper. Thank you.
Thank you.
Thank you so much, sir. As we come to the end of this technical session, I would like to sincerely thank all our authors for their excellent presentation and valuable contributions. I also extend my heartfelt gratitude to all the participants for being a part of this international conference. I hope today's session has been informative, engaging, and enriching for everyone. On behalf of the entire team, we thank you for your continued support during the 10th edition of World S4 2026, as well as throughout the previous 9 editions of the conference. We look forward to welcoming you again to the 11th edition in 2027. All presenters will receive their digital certificates via email within 2 working days. The conference publication will be available within 7 to 8 months. We kindly request your cooperation with the World S4 2026 team throughout the publication process. I would also like to express my sincere appreciation to our session chair, Dr. Nalinikant Joshi, sir, for successfully chairing this technical session.
Thank you.
I request sir to please share their remarks on today's session.
So first of all, thank you, Samruddhi, to conduct this session successfully and smoothly in a time-bound manner. And the paper selection for this session was very good, especially one paper from the India and one paper that covers the last paper, clinical, and also the paper covers the financial aspect. So they were presented are very mature and they had done a very exhaustive work in their presentation. So it's very informative and useful. And all the papers have very good future scope if they keep working on those papers. And thanks to the GR Foundation for providing us this opportunity. Thank you.
Thank you so much, sir, for your valuable guidance. I would like to request you to kindly accept this certification on behalf of Team WS4 2026 Global Knowledge Resource Foundation and our partners. Please accept the certificate as a token of our appreciation for your valuable support and contribution. Thank you once again for your valuable presence and participation. This concludes our session. Before we end, I kindly request everyone to switch on their cameras for a quick group snapshot of our virtual conference. Please switch on your cameras. Thank you so much, everyone. Take care. Have a good day. You can leave the meeting.
Thank you.